Hello, everyone. All right, let's get some intro into Python going on here. Just a little background on me. I have been a director of data analytics for a large tech company, and I think it's really important to get a lot of the technical aspects of internal audit out into the world, because I think it's a little different than regular needs of data analytics in general. We have to interact and get evidence of the real world, of approvals, of journal entries. We have to take a lot of screenshots. So we have to do a lot of things that humans do. And there are some ways to do that with the machine. So one of the things, one of the platforms that's great about that is Python. So there's a lot of other things you can use to automate. You can use UiPath, you can use Automate Anywhere. And this isn't just about automation, it's about machine learning and everything. But platform is important, and Python is a very good platform for this. Okay, so what we're going to do is we'll jump right into it. So Python is a programming language, and it's just like a software package. You can put it directly on your machine. And there's a lot of different ways to interact with Python. But what we're going to do is we're going to put it on our machine. We're going to go through an IDE, or an interactive development environment, a very simple one. And then we're going to go through an example of getting data and then testing it. As far as Python goes, we're going to do some Python, but it's going to be pretty advanced. I'm going to get you dangerous right away. And hopefully this is kind of a real world example to get you going. Again, if you want to learn the regular Python language, the for loops and the if statements, go to W3 Schools. Great stuff. But what we're going to focus on here is really enough Python to get started, as well as introducing you to a package called Pandas, which is basically the Excel of Python. And that's the important stuff. So let's get going. All right, there's a lot of different ways you can get Python on your machine. You can do it through your IT department. Make sure they have a system or subscriptions. Oftentimes a large company will have something like Anaconda, which is a Python wrapper, which makes dealing with Python a lot easier, especially for corporations. But we're going to go native Python basically here. So you go to python.org, right? And before you start to download or anything, we have to see if Python is on your machine. So you're going to go to the search bar and you're going to go CMD. So you'll get your command prompt up. You could also do PowerShell or whatever you want, but it's basically the DOSy part of your machine is what we are really interested in here. So I'm going to make this a little larger because we're going to be using this for a little bit. So right at your first command prompt, you're going to do Python, and then you're going to go double dash and then version. And you're going to find Python was not found. If there is no Python. If there is Python, you're all ready to go. And that's terrific. All right, so one of the things that we have to look about is okay, so you have Python on your machine. Now, Python is, if you load it on, it's just the native language. But Python also has a thing called packages or modules, which is software that is added on to Python. It's basically people have gone out and already written a lot of code that makes things easier for you to do. So you don't have to start from basic Python to start doing really advanced stuff. In fact, Python is incredibly good with this. Someone somewhere has written a package for what you want to do. If you want to, read a certain type of database, like a Terra database, that's been actually written. If you want to interact with web-based controls or websites, that's already been done. So those are the packages we'll go over, but packages are really important. So let's see what we have as far as packages. All right, one way you can do is Oh yeah, so now that we know that Python is not on our machine, we want to download it. Okay, so we're gonna X out of this, bye-bye, and we're gonna download. So there's a lot of great documentation and jobs and get started on the Python website, so you can look around there, that's great. But we're gonna go to download. Now Python 3.13.3 is the most stable current release. You click through and it tells you all the different stuff that's new to Python 3.13.3. And that's a little more advanced, but it's interesting to read. So you find the one that's recommended or installer or what's best for you. And in fact, for me, I'm doing it on Windows, so it's going to be Windows installer. And you'll see that we've downloaded the Windows installer. So we're going to open it up and just double click it to get it started. Just like any other software program, just like Excel, just like anything you would put on. And it comes up with this. Now this gets a little crazy. So you're going to do install now, or you can do custom installation. We're going to do the regular installation here. That gives you kind of all of the pieces, almost all the pieces right off the bat. Now, there's going to be a box down here that says add Python X2 path. What this does is it adds Python to your environmental paths, variables, so that your computer, when you say Python, it knows where to go. Like if you were back in the DOS, you did Notepad, it would open Notepad. If you did Excel, it would open Excel, because those are in your environmental variables. So now that we know that Python is not on your computer, and this is the only installation of it, we would do add Python exe to path. I usually do the use admin privileges because Microsoft made me back up to the cloud, and it all messed up some of my stuff that I'm still going through, but I have to use admin privileges to put this on now. And then we're going to do install now. So we install, and just like any other software program, we can see it bringing on software on your machine. Make sure you've got enough room to do it. So after this loads, what we're going to do is we're going to look at and make sure that we have Python on our machine. The next thing we're going to do is we're going to see what packages came in the base version of, or whatever this version of Python is. Now, we're also, if we don't find those packages that we're going to be using during this demonstration, we're going to add them. Okay? So that'll be the next steps as we go through. Oh, also, like I said, I do have a GitHub I think I put it in the description of the YouTube video. And if you want to follow along, you've got the 2019 data. There's actually, I've done this a few times, there's the actual code that we're going to make today. And if you want to go to Kaggle, or if you want to have data sets that are useful, you can go to Kaggle. And I found this airline delay analysis, and that's what we're going to be using today. All right, setup was successful. All right, since it was successful, let's go back to our command prompt. CMD, it'll give you right there. You can click it, and it'll open it up again, and then we'll see what we have. So in this case, we do Python. And like I said, now that we have added it to path, your computer knows exactly which Python it's going to go, and we're going to ask it, what version of Python do we have? Now we have Python 3.13.3 on our computer, so we are ready to go. Okay, so we talked about what kind of packages we need. So there's one thing you can do, is an important package handler or program we're going to have is pip. Pip is a program within Python which allows you to add modules. So the modules are out in pypy.org, and all of these different packages or modules are there for you. If you know which one you want to put in, you would use pip to install it. In fact, we're going to go through that in a little bit. But pip can do a few other things. So let's do a list. Let's see what packages we already have on here. Okay, so it looks like I have a ton of packages, and the two most important for me is going to be pandas. All right, so pandas is in this. 2.2.3. Again, pandas is the Excel of Python. And then the other one is Spider. Spider is going to be our IDE, our interactive development environment. And that's going to allow us to write code and see it work and then create it. It's basically like a Word doc. And you write your code in the Word doc and then you save it. As simple as that. So let's say that we didn't have pandas in our package list. We would do pip install pandas, and then we would enter. And what that would do is Python pip module would go out and look for the most recent versions of pandas and see if we got it. So now this requirement is already satisfied. So pandas is already here, so it basically said, okay, pandas is already here, don't put it in. But if you are missing these packages, you would do pip install pandas. Okay? All right, excellent. So Spider is on our machine, and what's great about it is you just do SPYDER, and you press enter, just like you're calling up any type of program. Now, when you first load it on, it takes a little bit to load up. After the first time, it's much quicker. But there are a lot of different IDEs, and the IDEs can be interactive development environments, can be like PyCharm, it can be VS Code, it could be almost any of the ones out there. There's actually a native one within Python that's pretty basic. Now, what these interactive development environments do, or IDEs, is they allow you to create code, run code locally, and see what variables you've seen. So I'm going to bring it over. It popped up on my other screen here, and I'm gonna. If you do, just say dismiss. If you ever have to change Spider from one side to another, just do dismiss, and it'll get rid of it. Okay, so it looks pretty good right here. Okay, got it. All right, so let's get this full screen here, and I'm gonna get rid of that. That was from last time, and that's what we're gonna write. So Spider, this interactive development environment, is pretty simple. We have one window, which is the editor. This is where we create a document. It's almost like a notepad. You can see I've got a little clip up here. It's untitled, so I could put and I can type in here. So this is for demo for intro to Python. All right, and then what we can do is we can type again here, and let's say x is equal to 1. We have just written our first line, and we can save this. So if we do file save, or we could click this little button, we'll do file, save, or save as, and it'll bring you to the place you want to go to. If we have, let me see if Spider. Okay, so let's go into Spider, and I'm going to put, in fact, we're going to do this one as test, and we're going to replace it. But you could name it anything you want. Again, that was just to show you that this is exactly like a Word document. So if I close this, so if I just close this thing, right, and I go back here and I go open, and I find the file in the Spider, and I go delay test, you can see again our script is back. So this is where you keep your permanent script. Again, it's just like a notepad. So this is a Python file. So we have this, and then over here we have a couple of columns as well. So this is the editor, and this is the console. So if the console is where you have live Python. So if I do x is equal to 1 and hit enter, I have a new line here. Now, if I do x I get 1. Okay? So this is the live Python. So what the console is good for is when you're writing, you can often just run your code right here, and then once it works and once it's in good condition, you can put it right back into here, paste it right into here. So I'm going to give you a little bit of Python that's important. So Python is an object-oriented language. That means we just created an object, x, or a variable, and we made it equal to 1. So another window that's important is the Variable Explorer. So if we go up to the Variable Explorer, we can see that we've created one variable. It's x, it's an integer, so it gives you a data type, the size, and its value. So this is an object. Now, if we look at it, we can do x. Let's do this one. We can make another one. Y is equal to dog. Okay? And we've just created another object or another variable. Now, objects and variables can be different things. They can not only be a string or a number, they could be a website. They could be a full piece of data, which you're going to see in a little bit. They can be a model, a machine learning model that you can put data through to get output. So what you do is when you have an object, you have y, like let's say y, and then to get the attributes or the functions of that, you push dot. And then if I push tab, if I push the tab button, you can see that we can do a lot of stuff to this this object. So in each object, depending on what type of object it is, you'll have different functions. Okay, in this case, like if we do capitalize, so capitalize, and it's a function, so just like in Excel, we have to put if it's a function, we can put parentheses. And in this case, there's no attributes within the parentheses, so we can just do that. And you can see that even though the string dog was all lowercase, the capitalize created an uppercase letter in this case. Okay, so now we have a two objects that we've written. So if we wanted to create this, we'd put this over here like that. And let's say we wanted to actually print in the output here, we could do print object y dot capitalize and then that. All right, so what I'm going to do here is also I'm going to clear, see that we have variables here right now. When we start things, we have to clear it. So I'm just going to, I'm actually going to hit that, and it clears all the variables are gone. So your memory is kind of cleared of all the clutter, and you're starting with a completely new console. So if I run this, right, and again, I haven't saved it, but if I hit run on Spider, it'll automatically save it. You can see that the little asterisk has gone away. And you can see that it ran this file, and then it output dog, right? It printed dog, and then we have the variables. All right, that's enough Python. If you want to do any more like native Python stuff, go to W3 Schools. All right, I'm going to clear the console, and I'm going to actually clear the entire kernel because we want to clear that out. So in this case, what we want to do is we are at an internal audit team at an airline, and the airline has a bunch of subcarriers, and we need to test a control. Now, the control that operations has is that if delay departures of over 60 minutes is more than 5% of all flights, we have to take a sample of 30 flights, of 30 of these exceptions to test. Okay? So that's the that's the control that we're going to be testing. All right. So what we want to do is we want to start coding here. So the first thing is we want to import our package, our pandas in this case. So we're going to do import modules. And now it's important for when you are scripting to put in comments. And you can see that if you put a hash and a space or whatever, you can type. Now this is not code. This is just a comment, so that people, when they go through your code, they can know exactly what's happening. And one of the things I will say is, as you write, always comment as much as you can. So we put pandas. So pandas is a module, but it's not used in Python by default. You have to call it. You have to call the functions and the abilities of pandas from the package. So the way you do that in Python is import pandas. Okay, so this basically, oh, and the IDE is really good, because if you go on here, it'll tell you everything you need to know, and it'll also do code completion for you. Again, Pandas is a powerful data analysis and manipulation library for Python. Okay, and this is just an example, basically saying we've brought in Pandas, but we haven't used it yet. So again, it'll try to help you out. Now we're going to be calling functions from Pandas a lot, so I don't want to type Pandas every time. So I'm going to give it an alias. I'm going to as PD. Okay. Now we're going to do this. So we have basically created our first things. Now we can do save here. So we've saved this file as we need. All right, so for the test, what we need to do is we need to get this data. So this looks about 790 meg, so kind of close to a gig. So what we need to do is we need to read this, and what is it? We can see that it's a CSV, comment separated value file. So we need to import it. So we're going to do this, and we're going to do import data. And again, like when we were talking about X and Y, we're going to create the data as an object within Python. So we can call it anything we want. So we're going to call it data frame 2019. And you could call it anything you want. And what's great about Python is it's really intuitive. So you can make your variable names very English language, so everyone knows what it is. All right, so now we have the data over there, but we need to get it into Python. So we're going to use pandas for that. So how do we use pandas? And I'm going to switch over to the console because it'll be live here. So we do PD and then dot, right? We're calling pandas. Now we want to use the pandas functions. And if we hit, oh yeah, you know what? I've got to run this to bring pandas in. Again, you have to run it so that it's live. And then you hit enter, and you'll see pandas is not here. It doesn't show up as a variable, but it is available to us right now. So let's say pandas dot. Now we need all the functions. So you can see pandas does a lot of stuff here, and right off the bat. And here you can see the read functions. So I could read from a Parquet, I could read from JSON, HTML, HDF, Feather. This is a fixed width. You could read from Excel. In this case, we want to read from CSV. So I'm going to, once you hit tab, you can do read CSV. Now, what we want to do is read, and again, just like Excel, you need to do a parentheses. And using an IDE, it'll tell you all the things that you could do within the IDE, which is really useful. So in this case, all I really need is the file path to the file. So we know the file's here. What we're going to do is I'm going to right click and I'm going to copy as path, which has been a great thing. It used to be just typing these things out is a pain, but the file manager is much better. So I'm going to paste it here, and then I'm going to close it off. Okay, so now we have pd.readCSV, then we have the path, and then we have the close parentheses. So yay, everything will work. So if I press enter, yay, everything will work. Oh no, there's a syntax error. So the syntax error is something within the line that we just tried to run. Now Python is great because not only does it tell you what type of error it is, it tells you a description of the error as well as where in the line that you did it. So it was into line 1 right there. So in this case, I'm showing you this one because this one happens a lot, especially early on when you start coding. Python paths doesn't like the backward slash for a number of reasons I won't get into right now, but it doesn't like the backward slash. So there's 2 ways to fix it, and I'll show you that next. So what we're going to do is we're going to go to line 3, and all I have to do is push the up arrow on my keyboard, and it'll recreate the last line that I ran here. And in this case, okay, so it gives me back, so I know the error. It's a Unicode escape error. So I could either make all of these backslashes forward slashes, but instead I usually like doing R, which creates a raw string. Never mind what that means, but it gets rid of the problem. So at the end of the day, if I press enter, you'll see now that Python is thinking. Instead of giving me the error, you can see that it's working at this time. So when you have Python execution, you'll either have the next line or you'll have an error. So in this case, we had a successful run. So we have the data is in, so it's put out, and it's there. But the problem is, how do we use it? We just ran this code and it printed this out, this 7,400,000 and something lines. Well, what we didn't do is we didn't put it as a object, the df19. So we know that this works. So we're going to take this, right? And I'm going to put this here and V. So you can see that this line is now on it. So I'm going to actually show you something here. Is if you, in Spider, you can go on the line, or you can select a bunch of code, but you can go on the line and you press this little button right here, which is the code. You either run the selection or you run the current line. So you don't have to copy. You could do the whole selection, or if you're doing multiple lines, you do the whole selection. But here you just put it there, and all IDEs have either a full run or you could just run the code piece you have. So in this case, I'm going to run this again, and you notice that there wasn't a variable that got made when we just ran the line, because all we did was read the data and then it went nowhere. We didn't put it into the object. Now you can see that we have a data frame object, just like the variables X and Y we did earlier, and it's 7 million lines, 7,400,000 lines, and then we have these columns. Okay, so one of the things I like to do is when I have data here, data is hard to see sometimes close up within Python, especially this huge amount. So there's a couple of things we can do to look at it. All right, so we could do df 2019, and again I just hit tab and it finished. It knew what I wanted and it just finished it. Then I do, since this is an object, I can do functions and attributes off of it. So in this case, if I hit tab, you can see that it actually gives me all the columns, only the columns that have like no spaces in it, and then it gives me all the functions. Okay, in this case, let's just take a look at what the function shape will do. And now this isn't a function, this is an attribute. So if I put shape, it'll give me the shape of the data frame that we have. So this gives me the dimensions of the pandas like Excel worksheet, right? So it's 7,400,000 lines long and 20 columns wide. So that gives me an idea of what it is. So let's take, since this was kind of big here, let's take a smaller look. So let's do df 2019, and one way is you could take the first bunch of, like, let's take the first 20 rows. And again, I did head, which is a function. I did the parentheses, and then I put in 20. So it's going to take the first 20 rows of this data set. And there we go. It's honestly not much better because, you know, Python it's a huge data set. So one thing we can do, another thing, is we can do df 2019. We can do the columns. We can look at the columns. And again, I don't need to put a parentheses because it's an attribute. Again, you'll get used to that as you go through. So we can see that we have a bunch of columns. Okay, it's getting better. I can start to see stuff. And as you get used to Python, and especially pandas, you'll be able to work more and more in Python and pandas. But one thing I find hugely, I guess, useful is looking at it within Excel sometimes if you have a little thing. So again, I'm hitting an up arrow, and I hit an up arrow again, and it gives me this. Now in Python's great because you can chain functions together. And one function I use a lot is toClipboard. And then again, since it's a function, I put the parentheses on the end. And if I hit toClipboard, okay, nothing really happened, except I copied this first 20 to the clipboard. Now be careful, if you just copy this whole thing to the clipboard, you'd be copying the 790,000 megabytes. Okay, so let's see here. So if I do paste, we can now see that what the data looks like, except it's 7 million lines long. So we have the flight date, the date the flight was, which carrier it was, which subcarrier it was. We have the flight number, where it was from, the destination, the departure time, and what's interesting for us is the departure delay. Again, we're trying to see how many the control is the delayed departures over 60 minutes. What percent of total flights are they? So we have here a bunch of data, and in this case, I know this data. So if it's a negative number, the flight took off before the scheduled departure time. If it's a positive number like this, it came after. That's how many minutes after the departure time the flight was. So we'll be using this column right here, which is DEP underscore delay, departure delay. And then there's a bunch of other stuff we could use, but for right now, that's good. And then we have like destination, the origin. So this tells you where it's from. All right, so now that we know kind of what the data is looking like, let's do some filtering. So I'm going to show you how to filter with pandas. So again, I want to get you up and running and dangerous as possible. So to filter in pandas, it's a little strange, but you get used to it. It's a pretty elegant way of doing it. So df 2019. So we're going to take the data that we have. Oh, so let's decide what we're going to filter on. So we want to filter on the origin here. Let's say we wanted to grab out of all these 7 million flights, all the flights that had an origin of GNV. Okay. So what we do is we take the data frame, the data, and then I do a square bracket. And I usually think of the square bracket as where. So we're doing all the data, where the data, and then I'm going to do dot, and then I'm going to hit this. I'm going to take the column origin. Okay. So I've got the data where the origin column is equivalent to, so count them two equal signs, GNV, and then parentheses. Now, the quotes can be either single quote or double quote. It's kind of up to you, and it kind of depends on the structures that you're using. And then an end square bracket. Okay, so if we do that, okay, so we can see that there were 5,200 rows. So there were 5,200 flights originating from GNV. And again, if we wanted to do this, we can chain things together. To clipboard right there. So if we wanted that data right there, we could easily just deal with it we could just slice it, and then we'd have our little slice that we could do whatever we want to in Excel. Okay, so that's that data, and I'm going to make this a little bigger too. Okay, so that's kind of one of the ways to filter within pandas, and then what do we have to do here? Okay, so what we're actually looking for is we're looking for the control test, right? The control test, which is percent of departure delays over 60 minutes. Okay, so what we'll do here is we're gonna slice it. We're gonna slice the big data, and what we're gonna look for is we're gonna look for data flights that are greater than 60 minutes. So just like we filtered above, we're gonna take all the data that we have, 2019, and we're gonna take the DF, right? All the data, and what are we going to look for now? We're going to look for the departure delays right there. And what do we need to see is greater than 60. Okay, so if we run this, we got about 482,000 flights that had departure delays greater than 60 minutes. So those are our exceptions. That's the total exceptions. So we have a slice. What do? Well, know what we want to do? We want to create an object. We want to get all the, just like we did a clipboard, but in this case, we want to keep it within Python, right? We want to automate this test. And the only way to automate it is to take that slice, and then we're going to have to do some calculations off of it. So let's set, I'm going to hit the up arrow, and it gives me the departure delays. Okay, which was successfully done right there. And we're going to do departure exceptions is equal to that slice, right? And then in pandas, what you want to do is, it's just good form to do a copy. That way you don't mess with the original data. All right, so now we have a new object. We have our departure exceptions. And then we have, which is 482,000 rows, and then we have the overall data. So what was the test? What did we need to do? We needed to see what percent of departure delays over 60 minutes were of total flights. So in this case, we can do other functions with data. So now that we have a new object, we have our departure exceptions. I can take departure exceptions, I can hit dot, right? And I can do departure delay, and that gives me just the single column. So we can see that it matches the amount. We can see that they're all over 60. So again, I hit an up arrow, and what we could do is just count them. And that gives us the 428. So that gives a total count of the amount of delays. And again, don't worry about this stuff right now. We'll pretty it up later, or none at all. So what we want to do is we want to make that. So I hit up arrow. So we need to make this an object because we have that calculation. So I want to do count of departure exceptions. Okay, so now we've created another variable, count of departure exceptions. So if I do count and departure except, it'll give me the number that we have. So we've gone from our departure exceptions, and then now we have a count of what we need. All right, so let's get the other metric that we have to deal with, which is the total flights. So to get total flights, so let's just create a variable called total flights is equal to, now we're going to take the entire data set, 2019 dot departure delay dot count. So that gives us, a whole nother another variable, total departure flights. So that gives us how, the ones that had departure. Now you'll see that it's different. We'll deal with that in data cleaning later on, but let's just say they're the same thing right now. There's other ways I could do total flights, but I wanted to do the ones that had departure delay data. Okay, so now let's do the test metric. So the test metric would be count of departure exceptions divided by total flights. And that gives us a 6.6. So we have missed our test metric here. So again, the control was if the total number of departure exceptions was greater than 5%, we have to take a sample. So we're going to be doing that next. But we've done a lot of coding here in the console. So we need to actually get some of this stuff over here. One of the other things about an IDE is it captures all of your history as you go. So it makes coding, you can go back and grab the things you need. So what did we need to do? We needed to get the exceptions. So let's bring that over. Then what did we have to do? We had to do the count of exceptions. And then we had to do the total flights. And then we had to do this. But what was this? This was actually our test metric. So I'm going to call this the test metric. And it's going to be equal to that. All right, so that was our test. So now we have a final test metric out here. So that was history, just to let you know. So we're going to go back to the amount here. So let's say we have this. So we know that we failed the test and we need to take a sample from the departure exceptions. And since internal audit loves 25 or 30, let's take a sample of 30. Well, it's pretty easy. So we do departure exceptions dot sample. And again, it's a function, so we're going to do this. And again, sample returns a random sample. What's great about Python 2, there's documentation that tells you exactly how it does it. And you could change the sampling type. If you don't want to do uniform sampling, you could do some chi-square stuff or whatever you want to do. But in this case, we just want to take a random sample of 30 here. So if we do enter, up, so we just outputted a row of 30. But again, we didn't apply it to anywhere. We didn't create a new variable. So what we should do is we'll do sample. Oh, hold on. I'm going to hit the up arrow. And I'm going to do sample exceptions. And once I hit that, a new variable is going to be created, sample exceptions, and it's going to look like this. In fact, if you want, you could open it and it tells you exactly what it looks like. Spiders, don't do this on any large ones. Spiders, those spider previews are pretty slow. They can't handle large data very well. So we have sample exceptions. So now we have our sample exceptions. So let's put it somewhere. So now we have the data that we want to get out. So we could do to clipboard, but we want to have this a little more automatic. So we want to save this back as an Excel. So we can do, again, our object, which is our sample exceptions. Then we do a dot, right, to call up exception. Now, last time we read, so we read from. In this case, what we're going to do is we're going to go to. We're going to go to, and again, we could put it into almost any format that you want. But in this case, we want to put it into Excel. I'm going to hit at, put it in Excel, put this open. And then what we need to do is we need to put it in a path. So let's put it in this little output folder right here. So if I go back here, I go copy, and I go back in here, and then I paste it, and you'll see output, but that's not the end of the path. I need to name the file as well. So I'm going to do sample exceptions.xlsx. Okay, so I've put the entire name and sub file indicator, and then I do that. Now remember this, is that backslashes don't play well when you're doing file paths. So we want to put the R in front before we do this. So keep your eye on this little area right here. If we push enter, you'll see that sample exceptions has now come up here, and we have our exception. So, and now you can do your test metrics, test A and B. And what's great is Python could also probably do a lot of this too. But there, so that's where we're going to end. So we've done it here. So we historize it, and I'm just going to take this little bit, and I'm going to put it here, and I'm going to put take sample and save to output. All right, so here we just take the sample exceptions, which is created by the sample function, and then we save it. All right, but that's not this case. That only happened this time. What? And this is I'm a little extra here. I'm going to give you an if statement. What if the next time we do this with something else? And again, we'll talk about doing variable type of things, type of data pulls. What if this didn't do it? What if the test metric wasn't over 50%, over 5%? So in this case, we're going to do if test metric, and again, what's great about IDEs, it code finishes for you, test metric. I hit tab. If test metric is greater than, and what was the control, 0.05, and then colon. So that means that we have if a test metric is greater than 5%, and that ends that portion of the if statement. Now you'll see an X here, and you'll see that the code analysis expected an indent block after the if statement. So the way Python works is if you do an if statement, everything, you have to indent everything that is part of that if statement. So you'll see, again, if I undo this, you'll see the little code. It's not, the indentation level is wrong. Okay? So if the test metric is here, is greater than 0.5, then take the sample and do sample exception, and then save it to the file. Okay? So what I'm going to do is I'm going to delete this. Actually, I'm going to close this before I try to delete it. And save. I'm going to delete that. And what we could do is we're going to clear this console. Again, clear everything out. You can see all the variables disappeared. So what should happen is I'm going to run this. Now that we've saved, you'll see that this little thing, I could either save it. So this means that it hasn't saved, or I can run it. So what we're going to do is I'm going to run this now. You can see that there's nothing here. We're going to run it. So we get new data from next month, and we put it into 2019. Let's say, or the file is renamed, or there's a certain way to do the file. What it's going to do is it's going to pull the data. It's going to run through all of the data as well. So you can see we have all the data, and here's the sample exception file, because it was over 5% in this case. And that is how you create a Python file. That's how you do Python. If you're in internal audit, it's great. It really helps you and it's so transferable to whatever you do. It's super powerful. It's as powerful as anything you could want to do. Pandas is great to up to 75 million rows on my machine, which is I think 8 RAM or 16 RAM. If I wanted to go bigger, I would use other packages. Like if I needed to get into the billions, I would either use Polars or VAX, or I'd actually even do you could do PySpark. But whatever it is, Python is a hugely supported program. It can do a lot. And again, on future ones, what we're going to do is we're going to go through and we're going to add screenshotting. We'll do connecting to databases. We'll do manipulating websites. And then hopefully you can automate a lot of your processes, especially some of the sample testing as well as sample gathering stuff that's really a grind. Thank you so much. I really appreciate everybody's time. Again, I have the GitHub link on the thing brings you to the data set as well as the completed code.